Okay, welcome back. We're going to discuss some of the problems on the flip side of this equations of circles worksheet. Okay, and we're going to look at number 7. Number 7 is stated that you have a circle passing through the origin. It wants to be of radius 13, and the center is without known coordinates except for the x-coordinate, which is at -12. So I'm going to take a look at this in the sketch pad and see if we can make sense of this. Okay, so here is the line. Here's the line x equals -12. I drew that line because any point on that line has the x-coordinate of -12. So you can see here I'm clocking the coordinates of point D, which is at -12 something. But it has to be such that the radius of the circle from this point is going to be exactly 13. So I'm looking at the length of the radius of the circle right here, because that's simply the distance DE, and I want that distance to close in on 13. So it's very close to 13 there. If I keep nudging at it, we're going to force that to become 13, and we're closing on it right about here. We're exactly at 13, and with that marked at 13, we see that the coordinates of D are -12 and -5. Okay, so we have the center, we have the radius, therefore we have the equation of the circle. Now, of course, you want to know algebraically. Well, what you're doing is you're computing the distance formula applied to the points at E, which is 0, 0, and at D, which is -12, comma y, because that could effectively be anything. Now, we'll also see that there's another location where that becomes the case, and it's up here. You can see this is again closing in on about 13, and keep nudging at that a little bit, and there we are exactly. And the coordinates at that point, as you can see, -12, 5, okay, and the radius, of course, 13, and the equation of the circle containing both the radius and the center is as labeled. Okay, so there's two distinct points meeting that condition. And again, the explanation algebraically behind that is simply to say that the distance between the point 0, 0 and -12, comma y is going to be 13. So here, put them in the distance formula and work it out and solve for y. And you'll get two values of y, plus and minus 5. Number 8 and number 10 are very much the same. So I'm going to take a look at number 10 on the sketch pad. Okay, I'm going to first look at number 9. This involves completing the square again. Not a big deal. It's just that we have to, we're going to entertain the idea of fractions. So we gather our x terms together here. We gather our y terms together. That's here what you have initially, and here. Now, of course, we need to complete the square, which calls for half of this coefficient, and that's, of course, 2 squared, which is 4, which is then added to both sides, and then likewise half of this coefficient of, we don't worry about the sign because we're going to square it anyway, so that's 5, and the half of that coefficient, of course, is 5 halves the quantity squared, which I square on this side is 25/4. Okay, so we factor that now. X plus 2 the quantity squared. Y minus 5 halves the quantity squared. No, I didn't square it on this side. I squared it on the other side. We got 10 and 4 coming together as 14, and 25/4 as 6 1/4, giving us 20 1/4, or collectively 81/4 as the radius squared. So 81/4 is a nice number to take a square root of. It's 9 halves. So we have the circle. We have the circle whose center is at 2, 2 1/2, and whose radius is 4.5 or 9/2. So number 10, number 8 are very much the same. So as I said, we're going to look at number 8, number 10, and you can use the same reasoning to work out number 8. Okay, so we're gonna go back to Sketchpad and look at what I have drawn up for that. Okay, the line is a tangent line, and I converted the slope intercept for just for ease on the graph in Sketchpad. Okay, so we have to be tangent to this line. Okay, at the point 3,4, and also go through the point 11 too. So I've got that set up over here. Let's pull this out of the way for the time being. Okay, and here we are. Okay, so here is my line. Okay, A is my point of tangency, and B is another point on the circle. So in other words, A and B are both on the circle. In as much as A and B are both on the circle, I can reason that there's a chord AB. Chord is any segment connecting points on a circle. Of course, the largest chord is a diameter. Now, there's also an idea that if I took the radius and it met up at the midpoint of this chord, it would bisect it. It would bisect it perpendicularly. So the radius the radius will perpendicularly bisect the chord. So knowing that idea, I'm going to construct the midpoint of that segment. Okay, and you can see what its coordinates would be. Of course, no big deal with finding the midpoint of that. Okay, and I want to also find the perpendicular bisector, which algebraically would mean I'd want to find the slope of this. Okay, so we will ask Sketchpad for the slope of that, and it says that the slope is negative 1/4. So the perpendicular, so we will ask to find the equation of the perpendicular bisector of that, and Sketchpad can draw that right there. Okay, and now, okay, what I know then is that there is a somewhere on that, there's a point somewhere on that perpendicular bisector, which is going to be the center of the circle. Now, of course, I could attempt to draw the circle from here, okay, and but it's going to be, you know, it does contain A and B, okay, but that's not the circle because the condition was that the A had to be a tangent, okay, so you know, any point on this perpendicular bisector will serve as the center of some circle containing the chord AB, but there's only one circle. Now we can see as I'm moving that up, and I'm going to slide that up a little bit, that that it looks like more and more like we're getting a tangent at A. So, well, let's go and determine what do we mean by tangent. Well, we should remember that if it's tangent, then the diameter drawn to that point of tangency will be perpendicular. So I'm going to back up. I'm going to do the same thing that I did over. I'm going to do the same thing that I did over with the chord. That is, I'm going to find the line which is perpendicular to this line, 2/3 x plus 6, negative 2/3 x is 6, perpendicular to that, okay, at this precise point of 3/4. So I'm going to ask to construct that perpendicular line, and your reasoning should stand correct that the center is going to be at where those two lines intersect. So I'm going to have to come up here, and once I close in right on that point, I'm going to meet my condition. So so what do we have to do? And I'll just let me just illustrate that for you here with the sketch pad. So I've got these 2 points. I want to identify their intersection, and I want to know the coordinates of that intersection, because the coordinates of that point, which are a little awkward they're not exactly integer values, but be that as it may, okay, we can see that once this point is driven up towards there, then that is exactly the circle we're talking about. And of course, what I'd like to know is what is the equation of that circle. And of course, it's the equation of that circle is the equation that goes through through these points, okay, through that point, and contains 3, 4, and 11, 2. So as a collective approach to algebraically outlining what you have to do, okay, we have to find the chord AB. And AB is the chord going through the 2 points given. We have to find the perpendicular bisector of that chord. That is implying the midpoint of that chord to be bisected, and the slope of that chord, so we can take the negative reciprocal, okay, as the slope. Okay, so we find the equation of this line DE. Likewise, we will go and take the tangent. We know what its slope is, it's 2/3, okay, and we know the point of tangency is at 3/4. So then we really want to find the equation of this line as well, okay, and that's right there, because then, and that's not so bad, because that is, of course, the equation of the line whose slope is 3/2 and contains the point 3, 4. So we have the line AE, we have the line DE, okay, and we want to find, and here we'll list for you what the line DE is, okay, and measure its equation, okay. Okay, so there's the line DE. All right, so those are the 2 lines. We want to find their point of intersection, which is right here, okay? So all these 3 things are vital. And that point of intersection is the center of the circle, and then you'd have to find the distance between the that point and the given point 3, 4, that would be the radius. And so that's the approach taken for this problem. It's a little bit of a algebraic nightmare in terms of what it involves, but looking here on Sketchpad, if you can get these the equations of the perpendicular bisector of the chord and the equation of the perpendicular to the tangent at the point of tangency, find their point of intersection, then you're well on your way of resolving that problem. Okay, and number 8 is going to be pretty much the same. So good luck with that.